Alright, let's begin. So for this video, we are going to be talking about sprites. So as you can see here, we have Stitch slowly growing and rotating. I can also update Stitch's position with some key inputs. We also have two texts over here. We have the caps lock text with the Times New Roman that the user inputted. And we also have this sentence over here using the tab key and also the default text. If I were to swap scenes, you can see that we have the origin testers I was talking about that can also be updated with character inputs. So as you can see here, all the origins are rotating at the 9 different points. And then if I close it, we have no leaks. So for the sprite tester, this is the one with Stitch. We are increasing the scale with an update call, and then we're changing the angle and the scale every frame. Drawing with 2D and using key presses to increment the X and Y. And then we delete that when we're done. Other sprite tester, this is the origin tester. It is rotating every frame. It is going to draw itself 9 times, each time changing its position and updating its origin to each of the 9 different points. And then we have the font tester. This uses the default font that I assigned as a preload, as well as a Times New Roman the user defined. Again, one uses the tab key, the other one doesn't. It draws itself in the 2D call, and then it deletes when it's done. Or deletes when it goes out of scope. For the draw, we have the draw manager over here. As we mentioned before, all the 3D objects are drawn first, and then all the 2D objects are drawn in front of them. For the actual code, we have the sprite over here. So we have the sprite that takes in a key, setting the angle of the rate by degree or radian, getting the angle, setting the scale by factor or by pixel, updating the origin, updating the position, rendering through a camera, and getting the width and the height. Inside of here, so when they give us a string, we try to find it here. So when we call the get over here, we check to see if the image exists. If the image exists, then we will get the image at that spot. Otherwise, we assert false and crash. After that, we can create a new graphics object. So the new graphics object will be at the default key here. For the model, it is the XY unit square. Default shader, we have the sprite renderer. Image singleton, we have the scale set to 1, 1, position 0, 0, origin 0, 0. Setting the width and the height, we have the origin width and origin height here. Setting the radian, degree by radian over here. Have the angle set to A. Setting the angle by degree, we have to do a conversion. Getting the angle is just getting it. Updating the origin. So the origin by default is at the center, so that's 0, 0. If they wish to update it, we have to take the halfway point of the width and the height, and then we multiply it by whatever factor they give us. As x goes negative, it shifts towards the left. As x goes positive, it shifts to the right. As y goes positive, it shifts up. As y goes negative, it shifts down. Setting scale by factor, we have they give us an x and y factor, we set it. Setting scale by pixel, we have to do division. They give us a width divided by the width of the sprite. Give us a height divided by the height of the sprite. Set the position, we have position x and position y. They give us an x and y, we set it. Updating the world. So for updating the world, we have a position vector, which is x, y, and is depth of 0, because we're using 2D sprites, so they don't have a z. Origin, it's the origin x and y that we defined earlier. The matrix is translation of the negative origin. The normal translation is a vector of the position. Rotation is around the z-axis with the angle provided. And the scale is done with the scale x and scale y. And once again, we don't have a z, so it's 1. For the world, we do the scale times the origin offset. This will move the position to the origin so that we can rotate around that spot. So we go to the origin offset and then we rotate, and once we do that, we apply the translation. Once all that's done, we set the world, and when the user is ready to render, it renders at that world position. And then whenever sprite is deleted, we delete the graphic object. SpriteFonts has a name, a texture, and it uses a map. It has an XML converter. So over here, whenever the user passes in a key, that becomes the name variable, whatever key they gave. After that, we load it into our texture singleton. We take that path and add the TGA, that is our texture path. And once we successfully load it in, we can set our font texture to be the texture at that key, and then we convert the XML file to gather all the remaining data. So this will give us the ASCII key value for the key as well as the X, Y, width, and height. So we load that into our image singleton with the name plus the character at that ASCII value. We define what the font texture was, so we can just pass that through. And then we create a new rectangle for the X, Y, width, and height gathered by the XML file. Once that's done, we can load that image into a new sprite. So we create a new glyph at that image location we just created. Set the origin to be the upper left-hand corner, and then push it into our font map. We do this for every single character. Once we're done, we create one more for the tab key, because the tab key is not in the XML data. So we have the name plus tab, default font texture, rectangle at the 0, 0, 2 times the width of the spacebar. You could do anything here for however long you want the tab. I personally do 2. And then the height value is 1 because it's just a tab. There's no actual characters. Once we do that, we create the sprite for the tab, set the origin to be the upper left, put it in at ASCII value 9, and that is our font map done. When the user wishes to gather any of the sprites, any of the glyphs specifically, they pass in the character that they want, and we use that, we convert it into its ASCII integer value, and we find the glyph at that location. When a sprite font is deleted, it goes through the font map, it grabs the sprite font from the map, and then it deletes it over here. For the sprite string, we have a list of glyphs. We have a sprite font, a width, height, position. We have all of that. We can get the height or width of the string, or of the sprite string, set the position, set the collection, update the collection if the user wants to change what the string says or change the font, and then we can render. So for the constructor here. So here, whenever they pass in the values, we just call the set collection. Set collection will take the sprite font that is passed in and make that the font for the sprite string. After that, we can set the height to be the glyph at the beginning of the height of the first character in the string. All of the characters in our TGA file have the same height, so we can just set it once to get it out of the way. After that, we loop through our entire string, get the glyph at the associated character in the string, increase the width of our sprite string by the width of our newly acquired character, and move on to the next one until we're done. And then we set the X and Y value to be what they pass through here. If the user wishes to update the collection, we have to first empty out our current sprite string and then reset the collection, so it just recalls this above function. When it's time to render, we will pass in the Y value and then this X offset. The X offset starts at position X, but as we iterate through our glyph collection and render each sprite, we are going to increment that X offset by the width value of the current sprite. This ensures that each text character is rendered to the right of the prior one, so it fully forms out its sentence. And that's it.